Have you ever wondered where algebra, the very foundation of modern mathematics, originated from? Hello, this is Singh Bros Institute. I'm Uday Pratap Singh. Today we talk about algebra. It's a vast field that we often take for granted, yet its roots stretch back to ancient civilizations. It's more than just a subject taught in schools. It's a powerful tool that has shaped our understanding of the world. From solving intricate problems to making groundbreaking discoveries, algebra plays an instrumental role in the realm of mathematics. Intrigued? Let's dive in and unravel the fascinating history of algebra. The story of algebra begins in the ancient civilizations of Egypt and Babylon. These cultures, flourishing thousands of years ago, laid the first stones on the path to algebra as we know it today, albeit in a form far removed from the algebraic equations you might be familiar with. In Egypt, the Rhine mathematical papyrus dated to around 1650 before the Common Era showcases a collection of problems that hint at the earliest inklings of algebraic thought. The ancient Egyptians didn't work with abstract symbols or unknown quantities as we do now. Instead, they used specific numbers and simple arithmetic to solve problems. However, the problems they tackled, such as those involving proportional reasoning and finding unknown quantities, are strikingly similar to the ones that would later be addressed by algebra. Meanwhile, across the desert in Babylon, clay tablets dating back to the second millennium before the Common Era reveal a civilization with a sophisticated understanding of mathematics. The Babylonians used a base 60 number system, which allowed them to perform complex calculations and solve quadratic equations, a fundamental aspect of algebra. Like the Egyptians, they didn't use abstract symbols, but their approach to problem solving was undoubtedly algebraic in nature. These early civilizations didn't have a concept of algebra in the way we do. They didn't write down equations or work with variables. Instead, they solved specific problems using arithmetic and geometric methods. But in doing so, they were laying the groundwork for the abstract algebraic methods that were to come. From these humble beginnings, algebra began to evolve and spread across civilizations. As it did, it would grow more complex and more abstract, gradually transforming into the algebra we know today, but that's a story for the next scene. The Greeks and Indians further developed the concepts of algebra. In the classical Greek period, a mathematician named Diophantus of Alexandria made significant contributions to algebra. Known as the father of algebra, he authored a series of books called Arithmetica, a collection of problems giving numerical solutions of determinate equations and indeterminate equations. His work, although largely focused on numerical solutions, paved the way for symbolic algebra and the use of symbols to represent numbers and mathematical relationships. Diophantus's work was characterized by the reduction of problems to simpler forms to solve equations, and the use of general methods applicable to many cases. He is known for his ability to handle fractional powers and roots, and his work introduced the concept of an algorithm, a systematic procedure for solving a problem. Meanwhile, on the Indian subcontinent, mathematicians were making their own strides in algebra. The ancient Indian mathematician Brahmagupta was one of the leading figures in this field. In his seminal work, Brahmasphutta Siddhanta, he laid down the rules for the manipulation of zero and negative numbers, a concept that was not fully understood or accepted in other parts of the world at the time. Brahmagupta is also credited with introducing the concept of solving quadratic equations and providing rules for square roots. His work represents one of the first systematic approaches to solving quadratic equations. Furthermore, his treatments of zero and negative numbers were revolutionary and formed the basis for much of modern algebra. While these civilizations made significant strides, the term algebra had not yet been coined. The journey of algebra as we know it today was far from over. It would take many more centuries and the contributions of numerous other cultures and individuals to fully develop this branch of mathematics. And the story of algebra's evolution is a testament to the collective human endeavor to understand and explain the world around us. It was during the Islamic Golden Age that the term algebra was born. A time of intellectual expansion, the Islamic Golden Age, spanning the 8th to the 14th century, witnessed a flurry of innovation and knowledge building in various fields of science, including mathematics. The Persian mathematician Al-Khwarizmi played a pivotal role in this period, particularly in the development of algebra. Al-Khwarizmi's seminal work, Kitab al-Jabr, marks a significant turning point in the history of mathematics. The term algebra itself is derived from this work. In Arabic, al-jabr roughly translates to restoration or completion, indicating the process of solving equations by balancing and transposing terms. Al-Khwarizmi's techniques were not altogether new. He drew upon Greek and Indian mathematical traditions, but it was his systematic and logical approach that set his work apart. In Kitab al-Jabr, he laid out clear step-by-step procedures for solving linear and quadratic equations, a major advancement in the field. His approach to algebra was primarily geometric. For instance, to solve a quadratic equation, he would reason geometrically and then translate the geometric solution back into numeric terms. This unique blend of algebraic methods and geometric thinking was a hallmark of al-Khwarizmi's work. Yet his algebra was not the abstract discipline we know today. It was a practical tool used for solving problems regarding inheritance, trade, surveying, and architectural design. It was devoid of any symbolic representation. Numbers and quantities were written out in words, and solutions were found through intuitive and logical reasoning. Al-Khwarizmi's work was revolutionary, but algebra was far from complete. The introduction of symbolic representation and the understanding of negative and irrational numbers were still centuries away. Nonetheless, Al-Khwarizmi's contributions laid the groundwork for these future developments, paving the way for algebra to grow and evolve into the powerful mathematical tool we know today. The development of algebra didn't stop with Al-Khwarizmi. In fact, the journey to the algebra we know today is paved with the contributions of numerous mathematicians, spanning across different centuries and continents. One such mathematician was François Viet, a Frenchman from the 16th century. He's often referred to as the father of modern algebra for his introduction of the use of letters as coefficients in equations, a practice we still use today. This concept of using symbols to represent quantities was a game-changer, marking the birth of symbolic algebra and allowing for more complex calculations and equations to be solved with greater ease. In the 17th century, another notable figure emerged, René Descartes, the French philosopher and mathematician. Descartes took Viet's work a step further by introducing the convention of using the last letters of the alphabet to denote unknowns and the first letters to denote known quantities. This notation system, still widely used in algebra today, set the stage for the development of Cartesian geometry, a system which links algebra and geometry and allows geometric problems to be solved algebraically. Then came Sir Isaac Newton, an English mathematician, physicist, and astronomer. While he is more famously known for his work in physics, his contributions to algebra were significant. Newton developed the binomial theorem, a formula for expanding powers of binomials. This theorem became a fundamental tool in algebra, calculus, and number theory. From ancient civilizations to the modern era, algebra has undergone a fascinating evolution. It has grown from simple arithmetic operations to a vast field of study with numerous branches and applications. It's a testament to human curiosity and the relentless pursuit of knowledge. The story of algebra is not just about numbers and equations. It's about the people who dared to ask why and how, and in doing so, changed the world of mathematics forever. So there we have it, the amazing journey of algebra through the ages. We've traversed time and space, from ancient civilizations to the present day, exploring the birth and evolution of algebra. It's been a journey of discovery, curiosity, and intellectual prowess, as mankind has sought to understand the world through mathematical lens. We've seen how algebra, in its earliest form, was utilized by ancient civilizations, where mathematical concepts were entwined with daily life, agriculture, and trade. We've explored the contributions of Greek and Indian mathematicians who used geometry as a tool to solve algebraic problems, laying the groundwork for future advancements. We've journeyed through the Islamic Golden Age, where the term algebra was first coined, and where scholars made significant strides in mathematical theory. This period marked a pivotal point in the history of algebra, as it began to take on a more recognizable form and its potential for solving complex problems was fully realized. In the modern era, we've seen how algebra has evolved into a sophisticated tool, used in every branch of science and mathematics, from physics to computer science. It's become a universal language, allowing us to express complex ideas and solve intricate problems. Next time you solve an algebraic equation, remember the centuries of thought and development that have gone into those seemingly simple symbols.